Welcome back, fellow math contest lovers. We're on question number 20 of the 2002 Grade 8 Gauss paper, put out by the University of Waterloo. And question 20, the last question to be worth 6 marks here. The units digit, that is the last digit or the rightmost digit, of 7 to the power of 62 is... Alright, simple matter, right? Just grab our calculator, because calculators are allowed. 7 to the power of 62. Oh, okay. More digits than my calculator can express. More digits than your calculator can likely express. So we can't just read off what the last digit is here. I've erased it, but what did I get? 2.48 times 10 to the 52, basically. So almost 2 with 52 zeros after it is the range, sort of where we're at here. So not the easiest thing to calculate. And with questions like this, where the calculation is hard or nearly impossible, things we rely on are pattern recognition. A lot of math, especially with the two Gauss contests, the younger contests, you want to notice patterns. Now, we're going to notice some patterns here in our solution here. It's based off a concept that you may or may not have heard of called modular arithmetic. And that's basically doing all the regular arithmetic operations, addition, subtraction, multiplication, and sometimes division, but using remainders of numbers rather than the number itself. And that's the basic idea. That's the basic pitch of modular arithmetic. Now, we're not going to get heavy into that. I just want to throw out some buzzwords in case you're interested in looking some of this stuff up. Modular arithmetic is very interesting, and it's working behind the scenes as we work out these patterns here. But, as I said, we're going to rely on patterns. So, let's take a look at some exponents, some powers of 7. And specifically, we're going to look at the last digit. So, if I were to say 7 to the 0, well, that's equal to 1. 7 to the 1, that's going to be just 7. 7 to the 2, that's going to be 49. 7 to the 3, 343. 7 to the 4, now this one you might need to use your calculator for. You might need it for 7 to the 3, but I would encourage you guys to memorize your cubes at least up to 10 cubed. 7 to the 4, 2,401. And 7 to the 5, that one I actually don't have memorized. 16,807. How about 7 to the 6? 11,7,649. 7 to the 7. I'm just going to keep going. 8,2,3,543. We'll do one more. 7 to the 8. 5, 7, 6, 4, 8, 0, 1. Now we can notice we're asked about the units digit, right? The last digit. So let's take a look at the last digit. That's 1, 7, 9, 3. 1, 7, 9, 3. 1, I bet you the next one will be 7. Well, let's test it. 7 to the power of 9, get our calculator out. It ends in a 7, a 0, 7 actually. Well, what's really nice is that we repeat. Our pattern repeats. Every fourth number is 3. So if we start with 0, every multiple of 4 ends in a 1. Okay. The powers of 7 are actually really nice because the last 2 digits are always the same. Or always have this pattern of 4. So that's pretty cool. I like that. But we're only asked for the last digit. So 7 to the power of n ends in Okay, so we have some cases here. a 1 if n divided by 4 has a remainder of 0. 3 if we have a remainder of 1. Sorry, 7 if we have a remainder of 1. 9 if we have a remainder of 2. And 3 if we have a remainder of 3. And we can double check that. Let's pick one. Oh, we've got a 9 here. 7 to the power of 6. 6 divided by 4 is 1 with a remainder of 2. And if we look that up, 6 divided by 4, remainder of 2, we should end with a 9. We do. 7 to the 3, well, we got a remainder of 3 when we divide by 4. Well, if we have a remainder of 3, we end in a 3, and wouldn't you know it, there we do. Okay. So this is just based on our pattern recognition. So for 7 to the 62, so when we divide by 4, we get 15 with a remainder of 2. And a remainder of 2 means we end in a 9. Okay, so which one of these was end in a 9? D. Okay. And that does it for question number 20, and that finishes off part B. We only have part C to go, where each correct answer is worth 8 marks. These are the really challenging questions. And we'll take a look at question number 21 on the 2002 Grade 8 Gauss in the next video.